Challenge is called rock, paper, scissors. It's named after the famous game we all learned as a kid. This is a common dispute resolution tool among children and adults alike, at least in America. It's what you think it is. We're making a little system that, given two player inputs or two rock, paper, scissors selections, we need to determine which player won. They gave us a nice little diagram here, or for those of you who are visual learners, you can see the three possible selections. We have scissors, represented by this hand gesture, we have paper, and we have rock. And you can see how rock beats the scissors, like it crushes them. The scissors can cut the paper, and the paper covers the rock. So that is how it works. They gave us some examples, make sure you understand. Again, scissors will cut the paper. So player one would be this left column, player two would be this right column, and you just say who won. Notice when the selections are the same, it's a draw. That's very straightforward. Let's get to the code. You can see what they have stubbed out for us to start. We have this kata class with an RPS method for rock, paper, scissors. We take P1 representing player one selection and P2 representing player two selection. For now, they just return the empty string, but this is our chance to shine. Go ahead and pause the video, have a go at this, and restart me when you're ready. Okay, we'll get rid of the boilerplate here. We have three cases to consider here, right? We have the option where player one beats player two. We have the option where player two beats player one, and we have the case where they have the same selection and it's a draw. Let's go ahead and get rid of that simple case first. We can say if P1 is equal to double equal signs P2, this will check the string's contents for equality. Then we're going to say return, and I believe it was draw. We can refer back to the instructions for the exact message. This first solution I'm going to go over with you, we'll just do it the straightforward way to sort of, the most basic way of getting through this challenge. And if you want to stick around for an extra credit where we learn some extra features of the language and branch out a little bit, then stay with me for that. Okay, so again, there's really only a few options here, right? So you can solve this all with a simple if statement after this. We know we would have returned already if it was a tie. So at this point, there's a clear winner, right? So let's just look at it arbitrarily from player one's perspective. We can say if P1 is equal to rock and the double ampersand is the logical and, P2 is equal to scissors. Make sure you're typing correctly here, it matters. And as we get into our extra credit solution, I'll show you that we typically don't keep typing out text like this. We'll define it in one place and reuse it. But anyway, or these double vertical pipes are a logical or. So P1 is equal to, let's say, paper this time. What would paper beat? So we're looking at the case where player one is better, and player one's going to be better when they have a rock against scissors, when they have paper against rock, or when they have scissors against paper. Okay. In either of those cases, we're going to return, I believe it said player one. Again, if I got the capitalization wrong, they'll tell us when we test. And then finally, right, we've returned already if it's a draw, we've returned if player one is one. There's only that third case I mentioned, we would say player two won. Okay, something like this should solve the problem. I'm going to go ahead and zoom back out so we can run some tests. The basic tests first, that's this list down here in sample tests, so we'll run through those. Okay, we got an error. Test failed on expected player 1. Notice the lowercase w and I used an uppercase W. So we'll just convert those over. If you would have had the instructions pulled up, you probably would have noticed that. Let's hit our test again. Good. All green, and I'll hit the attempt. That will run additional tests not shown in the sample test section here. And they claim that our solution is good. So you could submit at this point if you want to be done. As promised, though, I will I'll run through another way of solving the problem that might be a bit contrived, but will introduce some more programming concepts to you if you're up for that. So let's get into that without further ado. One thing, a good practice we can implement, like I said, is we wouldn't typically write these messages all out. That's very error prone, right? So typically what you'd do is you would define a variable to hold that. You would say private, let's say we'll call it a static read-only variable. This just means that it's defined in one place. It doesn't need to be reproduced for every instance of the kata class. Hopefully it's clear that we're not making a bunch of katas, we're just using this method. But that's okay if you don't understand, it's an 8 video. Private static read-only string, and we could call it, you can call it rock, you know? And this is going to look kind of dumb when you first start, but the idea is that when you type this out once, then your program oftentimes will have many instances of these. And so instead of having to type it out each time and risking a typo like I did with player 1-1, you can replace all these instances. And the other really nice thing about this, about not printing the text everywhere, is if you had to change the text for some reason, let's say that they decided they wanted a capital R. Now you only have to replace it right here in one location, and then everything else referenced rock. So if you didn't do that, you'd have to scan your entire program and replace every instance of it, which is definitely not fun. So you could copy this for paper and scissors if you wanted as well. Again, this is overkill for this example, but you're a hard charger, you're here for the extra credit, so I'm giving it to you. This is going to make you look like a real programmer. Because remember, we're not going to solve paper, rock, scissors in the wild. We're going to have real problems. Paper, and Control C, that's scissors, and scissors. And you could similarly define a win message. I won't do that here. But let's have some more fun. Let's make our own class to represent a rock, paper, scissors item. And what I mean by a rock, paper, scissors item, is that we're going to model this concept in software. That's the idea behind a class, is that it's a blueprint, where instead of just being stuck with dealing with strings and ints and the built-in variable types, we can define our own. So I'll call this a RPS item, for lack of a better term. I'm sorry, I need to call this a class. Just like look above, you can see kata, public class kata. And then we'll define a scope for our class. And then I like to start with the constructor. It's not a method, but you can think of it almost like a method that's called when your object is created. So you just say public and then the name of your class. And then let's think about what kind of data we want to store in here first before I implement this and before we decide what parameters to pass to it. So I'm going to say public string, and we could call it something like name, right? And then that'll just hold either rock, paper, or scissors. And then I'll say public string, and let's call it stronger than. And it's just going to say whatever type is beaten by this type. So for example, if we created one of these with rock, the stronger than would be scissors, right? Because rock beats scissors, that's the idea. And to not get too far down the rabbit hole, of course, we could actually override the less than or greater than operator, the comparison operators, and we could compare them like we might do with numbers. If you really want to go down the rabbit hole, I'll leave that as a investigation for you. I'm trying to keep this somewhat simple here at an 8 level. So I'm going to get rid of our other logic here, except for the draw, right? In any case, let's handle that quick case and just get out of here quickly if it's a draw. It doesn't need any more processing. So after that, it's either player 1-1 or player 2-1. But before we get to that, we also have to create our RPS items, right? We need to create the set of these items. We need the rock object, the scissors, and the paper one. Normally you would do this in a private field in the class, and because these things would be meant to persist long term. Note that since this is a method and we're going to define these in an array in the method, they would be deleted as soon as the method finished. So In a real program, you wouldn't want to keep constructing those items there. You would presumably use them long term and over and over. Let's get into it. We'll say RPS item array. I'll call it, let's say, items, and that could equal a new RPS item array. And I'm going to use these curly braces to initialize it, and I'm going to create the 3 objects in place. So I could say new RPS item, and before I got a little ahead of myself there, before we can invoke the constructor, let's implement it, right? So we're going to need a name and a stronger than. So we'll say string name. Notice I used lowercase to differentiate it, and I could say string stronger or whatever. It just has to be something that you can differentiate. Then I can simply say a capital name equals name and stronger than equals weaker, the weaker item. So there, now we can invoke the constructor. It's implemented. It's actually going to store the data. So we'll call one. I can actually use our variable now, rock, and the weaker one would be scissors, right? A comma for a new item. I'll say new RPS item. And then we could say paper, and that beats rock. And then we can create our last RPS item, which would be scissors, and paper. Scissors beats paper. Make sure you end with a semicolon. I apologize for not expanding my screen sooner. We can do that. So we define this array. Now we have this set of items, right? So now that we have that, our job is to determine, based on the inputs, string 1 and string 2, I'm sorry, P1 and P2, what we're dealing with, right? So let's locate those in this collection here. And I already noticed one other thing from copying. I better make sure, if we want our program to work, that I'm updating these as well. You were probably screaming at me as you saw that. That's good. That's good if you saw that. So, RPS item, I could say item 1. And then I'm basically going to scan through the items collection to determine which one I need. And I'm going to use something called link to do that. That's LINQ. So I have to bring in the system namespace here. Using system link for that. And I always encourage you to consult the documentation. I don't want this video to run too long. I've done this in other videos though, and you can always hit me up in the comments if you're not sure about anything in any of the videos that I do. So we could say equals items first, and then we give it a parameter, and I say item, the name property is equal to P1, right? That's player 1. I'm calling player 1's item 1, and I could say RPS item 2 equals items first. This just retrieves the first match in the collection, if you're wondering about that. Item name, as you could probably guess, be equal to P2, right? So now we have our 2 RPS items, and we can compare them now. We don't have to write out a conditional statement, at least not a compound one. I could just check if it's stronger, right? So I could say, and let's start with, let's set up our string result message, right? You can call it whatever you'd like. And I could say, bear with me on this. It's going to either say player 1, 1 or player 2, 1, right? But what's in common between those messages is I'm going to put the space and I'm going to put the 1 exclamation mark. And then the idea will be is that I'll just insert at the front of the string the appropriate player name. So I'm going to say if item 1 stronger than item 2's name, or you could just use P2 here as well. You could say return, and we're going to say result message, but like I said, we're going to use the insert method of the string class. Again, check your docs if you're new to that. And it has an option to provide an index. So I'm saying 0, meaning insert at the very front. You can think of strings as an array of characters, right? So position 0 would be at the very, very beginning, and then I could say what text I want. So I'm going to say player 1 in this case, right? And then finally, if player 1 didn't win, then we know it was player 2. I don't even need to bother to compare anything. So I could say return result message insert, add 0 again, but this time it's going to be player 2. And I didn't add the space after because it's preloaded here. Something like this should work. Let's see if I implemented that right. Let's run our test again, see what kind of errors I have. Okay, error non-invocable member, RPS item stronger than. Oh, sure. Again, good if you caught this. I use stronger than like a method, right? So I would want to say it's not a method, it was just a string property, right? In this case, it's a field, but a property would have a get set. But yeah, it's a string. So what I would have to say is when we compare strings, if item 1 stronger than is equal to item 2.name. Good. Let's try that. Let's see if we have any better luck. Good, green. Let's hit the full collection. Okay, good. So you could submit this way. Maybe I'll submit this way. When people see my answer, they'll get a chuckle and say, wow, that was overkill for a paper, rock, scissors challenge. But again, the reason I'm here is to teach. I want to really encourage you guys to make classes early on. I remember when I first started programming, that was kind of intimidating, but classes are your friend. Make your data, format it in a way that makes sense to you, that's efficient, that's consistent with the way you think about things. And hopefully other people too, the people you work with as well. So I'll go ahead and submit mine like this, I think. I don't think there's anything I needed to comment out here. I don't think so. So yeah, always remember, you put in the work, you watch the video, you learn something, make sure you submit and get those honor points too, okay? And finally, this is a chance to learn from other people too. You don't have to just learn from me. Scroll through some of these answers. Some are better than others, but maybe you'll see something in there that you didn't know about, and you can again consult the docs like this. Maybe this might be weird to you. So yeah, see what else you can learn from other people too. Otherwise, I encourage you to reach out in the comments, ask me some questions, give me your feedback. Otherwise, I'll see you in another video. Thank you.